The Kremlin refers to this missile system as the jewel in the crown of the Russian Empire, while Washington calls it Putin's Joker. Around 20 trillion rubles have been spent on the production of the Avangard over the last 10 years alone, but its total cost cannot be determined. It's important to note, however, that the presence of the Avangard has a very clear cost for the US, as these missiles essentially render the American missile defense system ineffective. The designations Jewel in the Crown and Putin's Joker are both quite fitting in military term. We are discussing a hypersonic glide vehicle, HGV, that flies to its target at hypersonic speed. It has a nuclear warhead ranging from 0.8 to 2 megaton. The HGV Vanguard appears unexpectedly on radar when there are only 15 to 20 seconds left before it reaches its target. Nearby observers see a fireball overhead. In fact, the Vanguard is flying in a haze of plasma, with its body surface temperature reaching 1,600 to 2,000 degrees Celsius in the thick layers of the atmosphere. Putin said that the 2-ton HGV can achieve hypersonic speeds of up to Mach 27 due to its wedge shape in the dense layers of the atmosphere, which is roughly 5.7 miles per second. This is faster than the first cosmic speed, meaning that even without a nuclear charge, the HGV Avangard can destroy any object in its path simply by kinetic energy. I agree that possessing such a weapon opens up strategic options. During the testing process for the HGV Vanguard, President Trump said that Russia was testing the current U.S. defense system. It should be noted that no single missile defense system in the world can handle such a fast target. Neither America, China, nor Russia itself. The American missile defense system, world's most advanced, cannot cope with the HGV Vanguard at 5.7 miles per second. Let's start with speed. Russia has 3 hypersonic missiles: the air-launched Kinzhal hypersonic missile, the Zircon hypersonic missile, and the HGV Avangard hypersonic missile. There has already been a strike using the Kinzhal and Zircon on the Ukrainian power grid, with confirmed speeds of Mach 8 to 10, 1.7 to 2.1 miles per second. According to Kiev Patriot, NASAMS, and Iris-T missile interceptors provided by the Allies successfully intercepted these missiles. Deep within Russian territory, the 13th Missile Division's new regiments are equipped with HGV Avangards. The way the HGV Avangard system works is that missile silos are dispersed several miles apart, so they cannot be destroyed simultaneously. It is believed that the silos' walls are lined with 120-ton armored hatches capable of withstanding direct hits from aircraft bombs or missiles. At a depth of 236 feet, each silo houses an intercontinental launch vehicle, the HGV Avangard, the missile's warhead, and the control center with the famous red button, all encased in a sealed capsule suspended in the silo on hydraulic dampers. Neither an earthquake nor a nuclear strike can shake the capsule in the slightest. The administrator's hand will remain steady. The Russian military trains 6,000 officers annually for a nuclear attack on the United States. The only operation Now, do you understand why Avangard HGVs are positioned in the Orenburg region? The location is far from Russia's external borders, making it difficult for American missile defense systems to detect the launch. Safeguard radars, however, the Russians pulled off another trick that made radars even more difficult to detect. The Avangard can either be deployed by the outdated Soviet SS-19 Stiletto missile, carrying 1 HGV, or by the Russian RS-28 Sarmat, known as Satan II. The Sarmat missile, by the way, can carry 5 2-ton Avangard HGVs. Due to the high amount of fuel required to overcome air resistance, intercontinental missiles are typically launched vertically to accelerate their exit from the dense layers of the atmosphere. Energy-consuming trajectories are used to bypass enemy missile defense systems. In real combat conditions, a lot of effort is put into making the launch vehicle undetectable for at least a few seconds. These seconds are crucial because 125 seconds after launch, the HGV Avangard separates. This is much sooner than the separation of intercontinental ballistic missiles with nuclear warheads. As such, U.S. missile defense systems can quickly detect launch vehicles and fire anti-missile rockets before they separate. Due to the HGV Avangard's early separation, the Sarmat carrier can fly beyond the atmosphere, not along the shortest path but through the South Pole. Why is this important? According to the Pentagon, American missile defense systems are designed to intercept conventional intercontinental ballistic missiles with nuclear warheads launched from Eurasia through the North Pole. If the launch vehicle moves in the opposite direction, and if the satellites don't detect its launch, the HGV Avangard can safely separate from the carrier and land in the area of U.S. missile defense just before impact. Here's how it happens in practice. First, the Sarmat missile heads in the direction opposite to the U.S. at Mach 15. The Avangard reaches a speed of 3.17 miles per second. After 125 seconds, the Avangard separate. Once the HGV is independent, it becomes fully autonomous. Despite not having an engine, the HGV Avangard has gliding capability, which extends its autonomous flight range to 3,700 miles. When the HGV Avangard separates from the carrier, gravity continues to accelerate it. Within the range of clear PAW or SBX radars, it performs dynamic maneuvers, up, down, right, left, and up and down again. It is true, however, that the U.S. missile defense system was not designed to handle highly maneuverable targets. Anti-missile systems were intended to destroy ballistic missiles, predictable trajectory, not to chase objects that, like UFOs, move chaotically through the sky. Space at a speed of 5.7 miles per second, so you might need to use several anti-missiles to destroy one HGV Avangard. To prevent this kind of attack, you should employ THAAD, a medium-range missile defense system. Russian President Vladimir Putin recently showcased a new hypersonic missile, the Zircon, which has sent shockwaves through NATO and global military circles. This missile, part of Russia's expanding arsenal, is designed to travel at speeds exceeding Mach 9, making it nearly impossible for existing defense systems to intercept. The Zircon's ability to carry both conventional and nuclear warheads adds to its threat, capable of striking targets with unprecedented speed and precision. The missile's demonstration, conducted during a high-profile military exercise in the Arctic, underscored Russia's intent to assert its military dominance in strategic regions. NATO officials expressed deep concern over the development, as the Zircon represents a significant advancement in missile technology, could potentially outpace NATO's current defense capability. The missile's deployment is seen as a response to NATO's expansion and its increasing presence near Russia's borders, which Moscow perceives as a direct threat. The introduction of the Zircon has forced military strategists in the West to rethink their defense postures and consider new investments in counter-hypersonic technologies. This development also raises questions about the future of arms control, as existing treaties may not adequately address the challenges posed by such advanced weaponry. The Zircon's capability to reach speeds that drastically reduce the reaction time for defenses means that traditional deterrence strategies may no longer be effective. As a result, this missile test has not only demonstrated Russia's technological prowess, but also heightened tensions, potentially igniting a new arms race focused on hypersonic weapons. The geopolitical implications are profound, as this development could destabilize the delicate balance of power and lead to increased militarization, particularly in the Arctic and Europe. Thanks for watching. Do subscribe for more.